Hey there folks, Mr. G here with another educational video. This is going to be our first one on the notes, and we're starting to talk about physical properties of matter, including density. Now hopefully these notes will help you understand them as we go through them, and I can add a little bit of commentary that will hopefully make this a little bit easier to learn. However, this is no substitute really for face-to-face help if you really need it. So I really would encourage you to post on Teams in our questions and answers channel, email me, or come during flex time to room A100. So if you remember, flex time is from 10:30 to 1:15 every single day. So if you have questions, please make sure you ask them. Now going through these notes here, my hope is that you can print these off. So these are already posted on our class team, so print them off and fill them out yourself. And the completed version here is already posted on the class team as well if you'd like. I would really encourage you to go through the filling out process because I do think it's important. And you can, if you have it printed out, you could follow along and fill it out as we're going through it right now. If you don't have a printer or you're not able to print this off, come by the classroom during flex time and I will have copies printed off that you can take. Same thing with all of the worksheets and anything else that would get posted. I have hard copies that you can grab if you don't have a printer. So today's date is November 19th, and this would be page number 1 of our unit here. You can put your name up here. Don't worry too much about the block right now. When we're talking about physical properties of matter, we have to first define what matter is, and that is anything that has mass and takes up space. So something that's heavy and it takes up physical space. A physical property is a characteristic of that matter that you can measure or observe, and it can help us identify what the matter is. So some common qualitative physical properties. So qualitative, this word here just means that there are no numbers involved. These are just descriptions. So something like color or flavor, so it's yellow or it tastes salty. The odor, what it smells like. Texture, how the surface feels. The state, solid, liquid, or gas. Lustrous is how shiny it is. Malleable is how easy it is to shape. And miscibility, or miscible in water, is basically can it mix with water. So for instance, oil can't mix with water. If you want to see some more information, these are the textbook pages that I encourage you to read. Our quantitative physical properties. Quantitative, this means that it has numbers. So a quantitative physical property is something that has numbers associated with it. So melting point, the temperature that a matter turns from solid to liquid, this is going to be a temperature. This would be our number right here. That's why it's quantitative. Boiling point, same idea, again, a temperature, solubility, so the amount of matter that dissolves in another type. So again, the amount, whether that's in grams or milliliters, that's going to be our number. Hardness, so this is a scale on how hard something is, and it goes from 0 to 10, where our 10 is a diamond, which is the hardest material, and 0 would be like something that isn't solid, like water. This scale would tell us from 0 to 10 how hard it is, so how hard the surface of the material is. Viscosity, so it's the rate that material flows. Again, rate, basically how much material is flowing. And if we have a high viscosity, it means it flows very slowly. So that's where our number comes from. Density, the amount of mass in a given volume. And this is something we're going to focus on for a little while here. So density is often measured in grams per milliliter or grams per centimeters cube. This is mass divided by volume. So these units, grams, tell us mass, and then whether it's milliliters or centimeters cubed, that tells us our volume. So this is the amount of mass in a given volume. And every substance has a density, and all of them are unique. So it's different for every single substance. And you can calculate it by taking the mass and divide it by the volume. So density is mass over volume, or D equals M over V. For example, water has a density of 1 gram per milliliter. This is the same as 1 gram per centimeter cubed. Milliliter and centimeter cubed mean the same thing. If you have a density that's less than this, so something that's less dense like foam, it will float on water. If it has a bigger density, something like metal, it's going to sink. And if we have an object that has the same density, it's going to float in the middle. So how is it possible for a small object and a large object to have the same mass? Well, the large object could have a low density and have the same mass as a small object with a high density. For example, on page 114, you could look, there's an image there. Another one we could think of is imagine we had a small little chunk of metal. If you ever picked up metal, it's usually pretty heavy. Or we could have a really large block of foam, like packing foam that's usually really light. But if we have enough of this foam, it could be really large and have the same mass as a small piece of metal. So that tells us this foam has a really small density compared to this metal, which has a really high density. But they could both have the same mass. So maybe they both weigh 1 gram. How would we find the volume of an object, for instance? If we want to use our density formula here, we need to know the mass and the volume. Mass we can measure usually with a scale, so like something you can stand on or put some of your substance on. Volume, there's a couple different ways that we can do this. We could measure it with a graduated cylinder, which is this picture down here. It's basically just a cylinder with a bunch of markings on it. If it's a regularly shaped solid, we can measure the sides with a ruler and calculate. So if we had a solid that's like a cube here, where it's nice flat sides, all the same in all of these directions, we could have the width, the length, and the height. So the volume of this would be width times length times height. So we could get the volume of like a brick of something like that. If we have an irregularly shaped solid, so that's something that doesn't look like this, we can use something called water displacement, which is basically you fill a graduated cylinder with a bit of water, and then you put your object in it, and you see how much the volume rises. And the difference would tell us what the volume of our object is. One thing that you want to remember here, though, when you're reading these, all of these graduated cylinders, anytime that you have a liquid inside, there's always a bit of a curve here, and we always want to measure from the bottom. So we always want to measure from the bottom of this. That's going to tell us where the volume is. And this little curve here, so when you have water or any other liquid inside of a container, there's a little curve. And the bottom, this curve on the top is called the meniscus, and we want to measure from the bottom of the meniscus. So let's look at some examples down here. Our first one here, we can see that when it's empty or just filled with water, we have a volume of 17 milliliters. When we have our battery placed in here, our volume goes up to 22 milliliters. For our nail, it goes up to 16, 17, 18 milliliters. Over here, we're at 19 milliliters with the button, and with the key, we're at 20 milliliters. So if we wanted to know the volume of each of these different objects, what we would do is take the difference. So the volume of our battery would be 22 minus 17, which is equal to 5 milliliters. Same thing here, 18 minus 17 would be 1 milliliter. 19 minus 17 gives us 2 milliliters, and 20 minus 17 gives us 3 milliliters. So that's how we would find the volume for our battery, our nail, our button, and our key. Once we know the mass and the volume, we can do our density calculations. So our first question here, if we have an 8 centimeters cubed block of brown sugar, has a mass of 12.9 grams, and we want to know the density. Density is mass over volume, so we can just plug this in. And we want to make sure that we're showing our work and our units. So our work has 3 steps, our formula, we plug in our numbers, and then our answer. And it's important to show all of these. And it's really important that you get the units right. It's one thing to remember here, we talked about it just beforehand. Centimeters cubed, that's the same as milliliters, and that would be a measure of volume. If we wanted to get, say, an irregularly shaped object, let's say we took our battery, the one from up here, and let's say it's 12 grams of mass. So our mass of the object is 12 grams. We have our initial volume of water, which is the volume when our cylinder doesn't have the battery, which was 17 milliliters. The final volume we got up here was 22 milliliters. So the volume of our object, like we calculated above, is just the difference, which is 5 milliliters. Now we can calculate the density. The density is mass over volume. So that's 12 grams over 5 milliliters, which would give us an answer of 2.4, but don't forget the units, grams per milliliter. If we're given a small piece of unknown metal and measure its mass, and it's 14.5 grams, why can't I just identify it with only the mass, and what other property should we use to identify the type of metal? The problem with just having the mass is it could be any type of material. The mass only tells us how much is there. The important thing that's unique for every object is the density. So if we got the mass and the volume, we could calculate the density and look it up. The important thing to remember here is that each object has a unique density, but we can have different amounts of each object. So if we want to identify what something is, we have to use the density, which means we need the mass and the volume. That's the end of our video here. Make sure you check Teams for all of the related reading, homework, and any other assignments that you have to do, and I'll see you all in the next video.